Good morning, everybody. Today I will be showing you my multi-core polynomial program. This is similar to my old program, which you can find on the LTT forums. This program is threaded and it inputs equations in factored form. So this is the equation you would put in. So the total solutions are the degree of the polynomial. You can put in any value for them. It has to be a whole number. So I'm going to do a 3, or in fact a 2 polynomial solution, which should make a parabola, similar to this. And the numerator of a is the a here. If a is larger, the polynomial will get stretched up and down, and I don't want that, so I'm just going to let it default to 1. Now the denominator of a is b, right here. And I'll make b 5. Now constant is k at the end. It's going to shift the entire parabola up and down, or in this case it's parabola. So I don't want that, so I'm just going to let it default to 0. Now the y-coordinate of the bottom left. So I've decided on the solutions beforehand. I'm going to do 10 and negative 10. So there's my solutions. A has to be at least 1, and B has to be at least 1. Okay, so this will just make a rather stretched parabola, like that, and flatten it out a little bit. There we go. So I'm going to draw it from here, negative 25, 15. So the y-coordinate would be negative 20, 5, and the x-coordinate would be negative 15. Now, horizontally, I will draw enough lines to get to 15. It should be 5, 10, 15, 20, 35, wait, no, 5, 10, 15, 20, 25, 30. So there's 30 horizontal lines, and I'll just draw it up to here. So it's negative 20 to 15. So that would be negative 25 to 15. Should be 15, 30, 35, 40 lines. Now the solutions I've already know. It's going to be negative 10 and 10. Now this automatically inverts them, so it's going to be negative 10 and 10 in this order. This automatically flips this to minus 10 because obviously this is inverted. If I make this minus 5, you can see that it's actually positive 5. Where's that? So this automatically inverts them. So if I put negative 5 here, it'll actually put it at negative 5. Now, the way threading works on this is, due to batch limitations, you'd want to do how many lines. Only one line can be computed by a single thread. And in this case, I can see there's 40 lines. It calculates them vertically. So for 40 lines, I'm going to be doing 8 threads. I have an 8-thread computer, and here you can see this. But my computer can probably calculate all 30 lines before a single thread has before 1 second has passed. So 16. So it will do 16 threads per maximum, 16 lines maximum per second. So I'll launch that. Now it's generated all the workers, and there we go. It's already done since I was a small program. And if you were paying attention here, you could see my CPU usage went up a little bit. Now there's some pre-computed ones in here, but it's automatically going to spit it out to the bottom of this. So as you can see right here, it's actually the same thing. It's a little bit stretched vertically because characters themselves are taller than they are wide, but it doesn't matter because it's still steps up 1 each way horizontally and 1 each way vertically. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the way that works. You can obviously enter much more complicated solutions by entering the degree of the polynomial being x minus, well, I'm going to leave that as x, which is plus or minus 0. Okay. Now, one thing you can do, since this is threaded, is you can have them generate rather large equations rather quickly. It would take quite a long time if you generate the largest possible you can do, which is roughly 8,000 by round about 32 billion. Not 32 billion, 32-bit integer. Actually 31 plus 1. So this is a pre-computed line I made. It's 200 by 400 or so graph, and it follows a simple equation. And as you can see here, it makes a nice smooth line. Now here's an issue. If your equation scales off into infinity this way and reaches roughly 2.8 billion, it will overflow and will become a negative number and will show up here. You'll see a very prominent vertical line, and ignore anything beyond that vertical line. There's no way to fix it because batch is very simple in terms of mathematics it uses. Now the equation, now the code for this is rather simple. It does not use that much code. That's about it. It just uses 98 lines of code, and that's about it. You only need this program. This is an old version. You don't need this. And you need to have read and write permissions to wherever you're storing this. If you place this in, say, a folder where you do not have read and write permissions, this won't be able to be outputted. And that's about it.